Hello everybody, welcome to Unmixed Tech. In our last video, we talked about artificial intelligence, but in this video, we will be talking about the most important subset of artificial intelligence, that is machine learning. As you know, we are living in a world of humans and machines. Humans have been evolving and learning from their past experience since millions of the years. In today's world, these machines are the robots. They need to be programmed before they actually follow your instructions. But what have the machines started to learn by their own? And this is where machine learning comes into the picture. Machine learning is the core of many futuristic technological advancements in our world today. You can see various examples of implementation of machine learning around us, such as Tesla's self-driving car, Apple's Siri, Sophia AI robot, and many more are there. So what exactly is the machine learning? Well, machine learning is a subfield of artificial intelligence that focuses on the design of the system that can learn from data and make decisions and predictions based on the experience, which is data. In the case of machines, machine learning enables computer to act and make data-driven decisions rather than being programmed to carry out a certain task. These programs are designed to learn and improve over the time when exposed to new data. Many people confuse between artificial intelligence, machine learning, and deep learning, but they are not same. To clarify, artificial intelligence is a broader concept that refers to the machines being able to perform tasks in a more intelligent way. This includes any technology that allows computers to behave like humans. Consider the famous Turing test, which aims to determine whether a computer can demonstrate human-like intelligence. If you have ever interacted with Siri on your phone and received an answer, you have already come close to experiencing this kind of artificial intelligence in action. So this was all about artificial intelligence. Now coming back to machine learning part. As I already said, machine learning is a subset and a current application of AI. It is based on the idea that we should be able to give machines the access to data and let them learn from themselves. It is a subset of artificial intelligence that deals with the extraction of patterns from data set. This means that the machine can not only find the rules for optimal behavior, but also can adapt the changes in the world. Many of the algorithms involved have been known for decades, even centuries. Thanks to the advances in the computer science and parallel computing, they can now scale up to a massive data volumes. So this was about machine learning part. Now coming over to deep learning. Deep learning is a subset of machine learning where similar machine learning programs are used to train deep neural networks so that to achieve better accuracy in those cases where the former was not performing up to the mark. Now that we have discussed in detail that artificial intelligence, machine learning, and deep learning are different fields. Each of them have their own unique characteristics and their features and application. Now let's dive deeper into different subcategories of machine learning, which is supervised learning, unsupervised learning, and reinforcement learning. Each of these categories have their own unique characteristics and have different use cases in banking, retail sector, and healthcare. So you don't worry, I will provide you enough examples and the use cases of all the categories to make you understand all the concepts. So starting with the supervised learning, what it is. So let's see a mathematical definition of supervised learning. Supervised learning is where you have input variable and an output variable, and you use an algorithm to learn the mapping function from input to the output. The goal is to approximate the mapping function so well that whenever you have a new input data, you can predict the output variable for the data. I think this was confusing for you. Let me simplify the definition of supervised learning so we can rephrase the understanding of mathematical definition as a machine learning method where each instance of the training data set is composed of different input attributes and an expected output. The input attributes of a training data set can be of any kind of data. It can be a pixel of image, or it can be the value of a database row. For each input instance, an expected output value is associated. The value can be discrete representing a category or can be a real or continuous value. In either case, the algorithm learns the input pattern that generates the expected output. Now once the algorithm is trained, it can be used to predict the correct output of never seen input. You can see an image on the screen. In this image, you can see that we are feeding raw inputs as an image of apple to the algorithm. As a part of the algorithm, we have a supervisor who keeps on correcting the machines or who keeps on training the machine. It keeps on telling him, yes, it is an apple, no, it is not an apple, things like that. So this process keeps on repeating until we get a final trained model. Once a model is ready, it can easily predict the correct output of a never seen input. In this slide, you can see that we are giving an image of a green apple to the machine, and the machine can easily identify it. as yes, it is an apple and it is giving the correct result, right? Now you might be wondering why we call this category of machine learning as supervised learning. Well, it is called as supervised learning because the process of an algorithm learning from the training data set can be thought of as a teacher supervising the learning process. As we know the correct answers, the algorithm makes while predicting on the training data and is corrected by the teacher. The learning stops when an algorithm achieves an acceptable level of performance. Now let's see some of the popular supervised learning algorithms. So we have linear regression, random forest and support vector machines. These are just for your information. We will discuss about these algorithms in our next video. Now let's see some of the popular use cases of supervised learning. So we have Siri and any other speech automation in your mobile phone trains using your voice. Once trained, it starts working based on that training. It is an application of supervised learning. Suppose you are telling, okay Google, call Karan, or hey Siri, call Karan. You get an answer to it and the action is performed and automatically a call goes to Karan. So these are just an example of supervised learning. Another example is biometric attendance, where you train the machine and after a couple of inputs of your biometric identity, be it your thumb or your iris, once trained, the machine can validate your future input and can identify you. Now comes the healthcare sector. In the healthcare sector, it is used to predict the patient readmission rate by building a regression model by providing data on the patient's treatment, administration and readmissions to show variables that best can correlate the readmissions. Next comes the retail sector. In the retail sector, it is used to analyze the product that a customer can buy together. It does this by building a supervised model to identify frequent item sets and association and the rules from the transactional data. Now let us learn about the next category of machine learning, the unsupervised part. Mathematically, unsupervised learning is where you only have the input x and no corresponding output variable. The goal of unsupervised learning is to model the underlying structure and distribution in the data in order to learn more from the data. So let me rephrase this in simple terms. In unsupervised learning approach, the data instances of a training data set do not have an expected output associated to them. Instead, unsupervised learning algorithm detects patterns based on the characteristics of the input data. An example of machine learning task that applies unsupervised learning is clustering. In this task, similar data instances are grouped together in order to identify clusters of the data. In this slide, you can see that initially we have different varieties of fruits as inputs. Now these set of fruits as an input are given to the model. Now once the model is trained using unsupervised learning algorithms, the model will create clusters on the basis of its training. It will group the similar fruits and makes their cluster. Despite the ability of grouping similar data into clusters, the algorithm is not capable to add labels to the group. The algorithm only knows which data and the stances are similar, but it cannot identify the meaning of this group. So now you might be wondering why this category of machine learning is named as unsupervised learning. So these are called unsupervised learning because unlike supervised learning, there is no correct answer and there is no teacher. Algorithms are left on their own to discover and present the interesting structure of the data. Let's move on and see some of the popular unsupervised learning algorithms. So we have k-means algorithm, a priori algorithm and hierarchical clustering. Again, this is just for your information sake. We will discuss about these algorithms in our next videos. Now let's move on and see some of the examples of unsupervised learning. Let's suppose you have never seen a cricket match before and by chance you watch a video on the internet. Now you can easily classify the players based on their different criterias. Like players wearing the same kind of jersey are in one team, players wearing a different kind of jerseys are in different team. Or you can classify them on the basis of their playing style, like the guy is bowler or he is in one class, the guy is a batsman, he is in another class. Or you can classify them whatever the way you observe the things. So this was an example of unsupervised learning. So now why this learning is different from supervised learning? Since you did not use your past or prior knowledge about the people, you kept on classifying them on the go. As they kept on coming, you kept on classifying them. This category of the people belong to this group and that category of the people belong to that group and so on. So now let's move on and see how unsupervised learning is used in the sector of banking, healthcare and retail sector. So starting with banking sector, In the banking sector, it is used to segment customers by behavioral characteristics by serving prospects and customers to develop multiple segments using clustering. In healthcare sector, it is used to categorize the MRA data by normal or abnormal images. It uses deep learning techniques to build a model that learns from different features of an image to recognize the different patterns. Next is the retail sector. In the retail sector, it is used to recommend the products to a customers based on their past purchases. It does this by building a collaborative filter model on the past purchases by them. I assume you guys now have a proper idea of what unsupervised learning means. If you have slightest doubt, do not hesitate and add your doubts to the comment section. I will try to answer them as quickly as possible. So let's discuss the third and the last type of machine learning, that is reinforcement learning. So what is reinforcement learning? Well, reinforcement learning is a type of machine learning algorithm that allows software agents and machines to automatically determine the ideal behavior within a specific context to maximize its performance. The reinforcement learning is about interaction between two elements, the environment and the learning agent. The learning agent leverages two mechanisms, namely exploration and exploitation. When learning agents acts on trial and error basis, it is termed as exploration. And when it acts based on the knowledge gained from the environment, it is referred to as exploitation. This environment rewards the agent for correct actions, which is reinforcement signal. Leveraging the rewards update the agent improves its environmental knowledge to select the next action. In this image, you can see that the machine is confused whether it is a cat or it is not a cat. Then the machine is trained using reinforcement learning. If it makes correct decision, it gets rewards point for it. In case of wrong, it gets a penalty for it. Once the training is done, now the machine can easily identify which one of them is cat. Right now, the machine will update its policy and this will continue until the machine gets an optimal policy for the next time machine will come to know whether it is a cat or not. Let's see some of the use cases of reinforcement learning. But before that, let's see how Ajay trains his dog using reinforcement learning and how he applied the reinforcement method to train his dog. Ajay integrated learning in 4 stages initially. Ajay gave meal to his dog and in response to the meal, the dog started salivating. Next, what he did, he created a sound with the bell. For this, the dog did not respond anything. In the third part, he tried to condition the dog by using the bell and then giving him the food. Seeing the food, the dog started salivating. Eventually, a situation came when the dog started salivating just after hearing the bell. Even if the food was not given to him, as the dog was reinforced that whenever the master will ring the bell, he will get the food. Now let's move on and see how reinforcement learning is applied in the field of banking, healthcare and retail sector. So starting with banking sector. In the banking sector, reinforcement learning is used to create a next best offer model for a call center by building a predictive model that learns over the time as per user accept or rejects offer made by the sales staff. In the healthcare sector, it is used to allocate the scarce medical resources to handle different types of ER cases by building a mark of decision process that learns treatment strategy from each type of ER cases. Now comes the retail sector. In the retail sector, it can be used to reduce excess stock by dynamic pricing by building a dynamic pricing model that adjusts the price based on the customer's response to the offer. By now, I hope you have gained better understanding of machine learning and must be eager to know more about it. If you found this video useful and helpful, please stay tuned for my next tutorial on machine learning. So make sure to subscribe the channel and hit the notification bell to stay updated. Till then, this is your host Vasudev Kaushik signing out. See you soon.